Good morning, ladies and gentlemen, to the second day of DevDays Amsterdam 2018. So, my name is Rene, and I'm a trainer / tutor for all sorts of interoperability standards, and I've done so for years. And today's topic is order management. And there's people who think, when they think about order management, they go like, that's like in the army, somebody gives you a command, and thou shalt do so. But to me, that's not true. The proper analogy to me is the conductor. And you think the conductor, but the conductor is also ordering everybody around and going like, well, thou shalt do this and level up and that sort of stuff. But that's not true. If the conductor doesn't have a good connection to the audience or to the orchestra, the conductor has to very closely listen to the orchestra and deal with the feedback. There's a lot more nuance in there than just giving a command. Now I can actually illustrate that. Okay? So you're going to be the orchestra briefly. Okay? And the music that you're going to meet is just to clap your hands. So if I ask this section over here to just clap their hands a few times, there you go, they respond. But I have to listen. Because what if they were to go like, nah, I'm not going to do that. That's obviously perfectly acceptable. Because if I now were to try the same trick over here, be prepared, there you go. You see, this is sort of driven by example. Okay? I'll get back to this. First of all, order management is all about request event workflow. It's about a request. I'm requesting, or in old-fashioned HL7 speak, ordering you to do something, and the event, the thing that subsequently happens once we have performed the requested thing. But the event can also occur without there having been any prior request. For example, I observe that the patient has a fever, then obviously there is no explicit request to deal with that. In general, when we look at the workflow for order management, we're talking about an order placer, in other words, some software application that has the capability to send orders or requests, and that's communicated to an order filler, and in our example today, that's going to be a laboratory system. The order filler communicates with an automation manager, which is linked ultimately to the analytics devices, which produces a test result, and the test result is communicated to the tracker. Okay, order placer, order filler, and the tracker. Those are the three main roles that we have here. Now, if you start looking at FHIR, what resources do we actually have to support those workflows that we have here? Well, certainly we have request. And request identifies the thing that we are ordering, the service that we are ordering to be done, and the request resource has a number of statuses to indicate whether or not this request has been performed or not, for example. Ultimately, that request will result in an event. In our example, that's an observation resource, and again, that has statuses to indicate the performance of the event. Are we still doing it, or have we already done it? Request obviously has a requester, somebody who is responsible for the request, and observation has a performer, somebody responsible for the event. And both are related either to a specimen, a laboratory, and or the patient. Okay? Now that sounds easy. I have a request, I have an event, in this case the observation. But what if we have a different interpretation on the filler side than we have on the requesting side? Sometimes you may be requesting something and then it ends up in the laboratory being their own request, their internal request, because they're effectively deciding to do something of their own, something that's slightly different, something that has multiple steps in it or something. So in addition to the observation, which we saw before, request and observation, we may have a request, a so-called filler order, within the context of a laboratory system. So that shows you all of the resources that we have, or the main resources in FHIR. Now we have resources, but if you look at RESTful FHIR, then REST is all about a repository model. It's about archival, more or less. So if I capture the details of a request, of an order, and I store that in an archive, it's like storing a PDF. Let's say I have a prescription in a PDF format, and I store it in an archive. Then, okay, it's sitting there. It's a nice record that there has been a prescription at one point in time. But there is no information in there as to who is supposed to actually perform this, or maybe it has already been performed. I have no clue. Okay? So in itself, it's not sufficient to just record the request, because that doesn't indicate to any party, thou shalt do something. I'm talking to you, you should do something. So that requires another layer, effectively. And that's where the task comes in. So task is the thing that tells you effectively, I want you to do, or I want you to cancel, or I don't actually want to do the thing that you are requesting me to do. So task sits in the middle and is manipulated, changed by both the order placer as well as the order filler that creates the event. And both can indicate in the centralized task who is responsible for the task, the owner of the task, and the status of the task. I have cancelled. I have performed this thing. Okay? So that's the core of this. And if we start looking at task, then this is the full task status diagram that we have. Okay? So we can go from ready, requested, received, accepted, rejected. We can go to in progress and completed, which is the normal status changes that we would have. But you see that it's a fairly rich expression of what we can do in this workflow type of resource, which is task. So if we go back to our laboratory workflow diagram, then it's not just about the exchange of the resources, but it's also about the workflow. In this case, the laboratory is going to own the workflow, because I request you to do something, which is I'm also requesting you to execute some sort of workflow. So the laboratory is also a workflow owner. It is the main manager, so to speak, of the task resource. Now let's have a look at an example. Now I couldn't resist. I knew that we were going to be in a room with 7 projectors. So obviously I'm going to use all of them, as you can imagine. Okay? So we start with our new request, right? So this is the part of the information model created by the placer system. They create a request with their own identifier, a unique identifier, status active. It's an active request for a sodium test in the category laboratory. And they create a task to indicate to any party out there that is willing to perform this particular lab test that this thing is now requested. Then the next step will be for a laboratory system to try and find out, well, is there any request out there that I can perform, that I'm able to perform? So step number 2 is to use polling or subscription to get hold, for example, of give me all tasks, okay, that are an order and an order in the category laboratory, so I can perform it. Or give me all tasks where explicitly the owner has been designated to be me. In other words, give me all lab orders assigned to me. Now there is some hidden complexity behind this. If you really want to get this right, then we're really looking at, in my mind, at an operation. For example, if I were to use a find task operation, what are the outstanding tasks that are relevant to me? It may very well be that then the central task management system is going to go like, Yeah, but I previously assigned this lab order to you and then you rejected it, so I'm not going to give it to you again. Or I know you're fairly busy in lab A, so I'm going to assign everything to lab B and not to lab A. I'm going to pretend there is nothing for you anymore. Load balancing. There's lots of complexity around this. Okay? Third step. The laboratory system, once they have found out that there is something that they can do, they accept ownership of the task. So now here we see that the task has an owner, which in this case is Dr. Klein. Because we are requesting a sodium test to be done for patient Adam Everyman. That's our scenario. And now Dr. Klein in the laboratory is assuming ownership for that particular task. Which brings us to step number 4. So now the order filler, the laboratory system, starts messaging that they are accepting, or they have accepted this, and the task now gets a status in progress. I'm actually performing the requested task. And yes, that leads to the observation, but as I told you, there may be a request on the receiver side as well, on the filler side, and the request could actually have a sub-request with a task that indicates that, for example, we still have to draw the blood from the patient. But let's assume we have the blood. Then we create a preliminary result. And the preliminary result will have, in the status codes, as we can see, the observation now is actually final. And we see that the task is being completed because this part of this diagram is managed and updated by the order filler, the laboratory system. But here we see that the request is still active. So as far as the order placer is concerned, they are not aware yet that their request has been performed. So once they discover that, hey, this lab system has set this task to complete it, then the requesting system can decide, finally, that my request is now completed. So you see that it's actually quite a dance, so to speak, between the order placer and the order filler. You can have all sorts of status transitions on the task, but even on the original request and or on the resulting observation. So it's not like, sodium, give me sodium, now, I want my sodium. It's a bit more subtle than that. Right? Although if you really wanted to, task as a resource is flexible enough to even deal with that sort of scenario, because it all depends on your context of use, right? That's why we have profiles, that's why we have implementation guides, that's why you have business rules. But let's look at the result side. This was about order management and results. Okay? So, first a bit of terminology, when you're not familiar with the structure of laboratory results. So we have the concept of battery. And we always tend to use laboratory examples because most of us are familiar as patients with laboratory order forms. You know, barcode, lots of check boxes, and you go like, okay, the clinician goes like check, 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 and it checks 5 boxes. But one of those boxes may actually be a battery. And a battery is a predefined set of atomic observations. They started with these forms in the 60s, and they found out that when clinicians ticked the box for white blood cells, they were also ticking the box for red blood cells and whatever. So there is always combinations. So you can then define a super box on this form that goes like, well, if you check this one, I will do 10 atomic tests. That's a battery, a predefined grouping of atomic tests. Plus, at a higher level, you may have something called an order group. Because the form that you are ordering these laboratory tests on is actually a grouper of multiple orders. Or think of the use case where in the emergency department they have a predefined list of things to do When the patient is delivered into the emergency department, let's say with car accident with head trauma. Car accident with head trauma causes these and these images to be made, these and these medications to be given in the first golden hour of treatment. A treatment protocol, effectively. Even that is an order group because it groups all sorts of order stuff together based on this protocol. So, that having been said, we have DiagnosticReport, a resource that we haven't looked at this point in time. It groups multiple observations, could also group imaging studies. And for that overall group, it basically collects or creates one textual report, effectively, that deals with everything that was in the original request in this case. Let's assume the laboratory order form, which had multiple orders in it. Okay? So it contextualizes and interprets, basically, the various bits of data. Now here we have an example showing the order. On the left-hand side we see two requests, but both of the requests, the first one for sodium and the second one for a battery CBC, that's a cell blood count, predefined battery, and then we see the two tasks, and the two tasks have output references in the form of the observations. Those are produced as a result of the task which is being performed. And all of those observations are documented in one single diagnostic report because that is effectively the equivalent of the group that we have also as identifiers here on the request. So that's an example from the laboratory domain. But there's actually lots of requests and event type resources in FHIR that deal with this. Because we have supply request. I want you to supply something, and then as an event type of thing, we have supply delivery. We have medication request and medication dispense. We have service request, which is the most wide-ranging request that we have, and it could lead to all sorts of events, resources being associated with it. And by the way, service request includes referrals. Okay, so then you already understand how wide-ranging this service request resource is. There's even a bunch of others, but I'm not going to talk about those. Okay? So what we have is a whole mechanism for dealing with the orders and the resulting events. And then we have to talk about the relationship with scheduling. And this is always a tricky subject, because quite often this is even today implemented in a strange, sometimes erroneous fashion. In the minds of HL7, okay, there is a clear distinction between the two. A request means I'm going to ask for your permission at some point in time, are you willing to do something? And then the answer could be yes or no. Right? But once you have accepted something, then you start doing the scheduling that, given that you agree to create this MRI image, how about next Tuesday with MRI number 2 and this technician, etc. So then you start talking about resources and you start talking about the timing. So scheduling differs from order management because one is to get an agreement in principle, are you willing to do it? And then the other one is tying the resources basically to that requested request. Now let's look at cancelling and modification of requests and orders. Okay. Or first, actually the referral. Okay. So how does a referral look like? Well, the referral is a request. As you have seen, it's a service request actually. It's an active request of a code that indicates I am a referral type of thing that I'm requesting. Here we have the requester, which is Dr. Hippocrates, who is also the creator of the task, and the task would then also be requested. Then we have an owner of the task, somebody that the referral is to, and that's either a practitioner, a care team, or a healthcare service resource. The output of the task would be the resulting encounter. Now the interesting bits are down here, because like in all requests, you can send supporting clinical information. And especially when we talk about a referral, you want there to be supporting clinical information in the form of binary documents, conditions, document references, observations, diagnostic reports, etc., etc. And especially in the case of references, you probably need to fill in manually a questionnaire defined by the organization that you're going to refer to. And then you populate that, a questionnaire response, and use that in the context of my request for a referral. But in and of itself, it's the very same mechanism that you have seen before. It's the general order, a request, task, event pattern. So how about somebody rejects some stuff? Okay, I go like, and nothing happens, right? Luckily for me, nothing happened. Okay. Anyway, so if I create a request and it's active with a task that says, well, I'm requesting you, Lab A, to perform this task, and then Lab A looks at this and goes like, no way. Okay. So then it would just change the status of this task to rejected. Computer says no, right? Then we assign here the requesting party, then says, okay, I'm going to create a new task based on the very same request. Okay? So I'm not modifying that at all. I'm just creating a new task to say, I'm now requesting Lab B to do this. And then luckily for them, they go like, okay. Change the status of the task to accepted, and then we see the rest of the workflow. Okay. Now, an example from the medication area about cancellation. So some task has been accepted, we're in the process of doing it, and then we're deciding to cancel it. So first, the simple scenario is that one of these two parties, so the party that's doing the medication administration at this point in time, or the party that created the original prescription, they want to cancel the whole process, then one of them can basically change the status of task to read cancelled. And then the other party should monitor that, and then they know that, okay, the other party has cancelled their part of this workflow. So if the filler changes this, they go like, okay, we are cancelling the medication administration. That doesn't necessarily mean that the prescription also is cancelled. Because it could mean that this party needs to seek a new person or a new department or whatever to administer that substance. And if somebody actually cancelled the prescription, you have to then find out, am I actually going to stop the medication administration? Because that again is a separate clinical decision whether you do that or not. And this is why we have this three-layer approach, so you can do all of these things independently. This scenario on the right-hand side is a bit more contrived, because now we have this scenario where Dr. Hippocrates has created the prescription for Adam Everyman, and it's done by the intensive care unit, and then some other clinician basically wishes Dr. Hippocrates to cancel that prescription. And this involves a new task, because the task is I'm effectively requesting a workflow. I'm requesting, in this case, Dr. Hippocrates to cancel an existing prescription. And that's why we have a new task, and the status is requested, and once accepted, they will then have to cancel that one. So to summarize, what we have seen: order communication results reporting. Okay. It's a request event pattern. Now you've certainly seen that in all of those, in most of the images. Request observation. That's the general pattern that we're looking at in all of these images. You can use tasks to explicitly capture workflow status. and I skipped it on the slide, but if you are not using task, the only way to inform a receiver that I want you to do something is to send it directly to them. Like me going like, I want you to applaud, and not you, all of you. Or to use messaging. If you use messaging, then there is an implied workflow mechanism in messaging to do that. Okay? But if you're not going to do that, if you're in a RESTful environment, then task is the name of the game to deal with this workflow stuff. And diagnostic report, okay, at the core of the classic reporting around, let's say, radiology, laboratory, that sort of stuff, that's at the heart of that kind of reporting. With that, I would like to thank you all, and I hope you can use this information. Thank you.